Hello, am I hello? Am I audible? And is my screen visible? Can anyone please let me know?
Yes, you're audible.
And is my screen visible?
Yes, yes.
Okay, thank you. So good evening to everyone. Welcome to this NPTEL live session for the course Introduction to Machine Learning. My name is Ayan Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is my 6th live session. In this live session, we will discuss some problems on week 6 topics. So week 6, in week 6, decision tree was covered. So I will discuss some questions on decision trees, and also I will try to answer your questions or queries. So if you have any doubts or questions, you can feel free to ask me anytime. So we will start solving some practice problems, and after that, if you have any questions, you can let me know. So this is question 1. The value of information gain in the following decision tree is, so you have to find out the information gain for this split. So this is the root node, and these are the two branches that are being created because of the decision tree split according to information gain. So and entropy for each of these nodes and number of examples belonging to each of these nodes are given, and using these formulas you have to find out the information gain for this split. You can write your answers in the chat. So for those who joined a little late, so this is the first question. You have to find out the information gain for this following decision tree. where this is the root node and these are the true two branches, and each node for each node entropy value and number of examples in that node are given. Option A. Okay. You can write your answers in the chat. So Deepak Srivastav is saying option B. Okay. Shruti is also saying option B. Anyone else? Vasudev Chauhan is also saying option B. Mriduvan Shah is saying B. Tanishq Badiyal is saying B. So all of the answers in the chat are option B. Okay, so for this question, so in order to find the information gain, I'm referring to as IG, information gain. So first thing is, you need to know the entropy of the parent node or the root. Here it's this one, 0.996, and then you have to subtract the total entropy of the children nodes, which will be weighted by the number of fraction of the examples that are going to each of these individual nodes. So the fraction of examples that are going to this left subtree is 17 by 30, and for right subtree that fraction is 13 by 30. So these are the weights for these two branches. So here it will be 17 by 30 into entropy of this node, which is 0.787 plus weight of the right subtree into entropy of right subtree, which is 0.391. So this is the formula that you have to use for to find out the information gain of this split. And if you compute this, it will come out to be option A, which is 0.380. Most of the answers in the chat were option B. So I'm not sure how exactly were all of you calculating it, but is this answer understandable, how I'm calculating this information gain? Okay, so if there are no doubts in this question, we can move on to the next question. Which of the following is true for a decision tree? There are four options. Decision tree is an example of linear classifier. The entropy of a node typically decreases as we go down a decision tree. The entropy of a set increases with its purity. An attribute with lower information gain is preferred to an attribute with higher information gain. Tanisk is saying option B, Deepak Srivastav is saying option B, Indu is saying option C. Archa is saying B, Rajarao is saying B. So most of the answers are B. The correct answer is option B. The first option says that decision tree is an example of a linear classifier. So the decision tree is certainly not a linear classifier. It can classify non-linear decision boundaries also. So it is not a linear classifier. Second option is entropy of a node typically decreases as we go down a decision tree. So this is right, because as we go down a decision tree, as more and more splits take place, the sets become much more purer. So as in the leaf node, only ones or zeros would be there in one node. So that means the purity increases as we go down the decision tree. So if purity increases, entropy will decrease. So option B is a correct answer here. And option C says the entropy of a set increases with its purity. So this is wrong. Entropy of a set decreases with its purity. Last option says an attribute with lower information gain is preferred to an attribute with higher information gain, which is also not right. So the decision tree algorithm is such that we will pick the attribute which has higher information gain. So option B is the only correct answer here. Question 3. Suppose we use the decision tree model for solving a multi-class classification problem. As we continue building the tree with respect to the generalization error of the model, what will happen to bias and error? So you have to identify what happens to bias and error in case of a decision tree. So first option is the error due to bias increases, error due to bias decreases, error due to a variance increases, error due to variance decreases. So what will happen once we continue building a decision tree? And multiple options may be correct in this question.
B and C.
Okay, B and C. Deepak Srivastav is also saying B, C. Archa is saying B, C. Raja Rao is saying B, D. Vijay Satish is saying B, C. Tanisk is saying B, C. So the correct answers are B and C. So most of you have given the correct answer. So if we build a tree which is deeper, in that case bias will be low. Bias is basically the error that you get in case of estimation. So it will decrease, bias will decrease. But if we make the decision tree too deep, in that case it becomes much more prone to overfitting, so variance will increase. So B and C are the correct answers. So as we continue to build the decision tree, it is possible that we overfit the data. In this case, the model is sufficiently complex, that is the error due to bias is low. However, due to overfitting, variance starts increasing. So because of this overfitting problem, variance would be increasing.
Sir, can we say that the properties of the decision tree is high variance? High variance is the property of the decision tree.
Not always. If you create a small decision tree, then that will not have a higher variance. But if you create a very deep decision tree, in that case variance will be very high.
So actually here we are taking which data actually? Generalization error means it is not the initial data, no?
Generalization error is test error basically.
But it will be like a U curve, no? So as we go deeper, it will increase only, no? Bias also will increase.
Bias, no. If you increase the depth, generally the bias would decrease. But yeah, in some cases also according to the U curve, it might also increase.
Because bias will decrease on the initial data, which the model was trained.
Yeah, bias. I mean, bias is not always the training error. Bias is basically your error of prediction.
So on the validation set, no, not on the test data. Training, validation, then test. Three
yes.
data sets are there, no?
Yeah.
So generalization means it can be option A also. It's not.
Generally, we consider that if you make the decision tree deeper, then even on test data, it might the bias would decrease because you are making a much more sophisticated model. So the error will decrease even in case of test data. But yeah, it might also happen the other way around, like if you make the model too deep, then test error might also increase. So it might happen. So generally what we say that if we make the tree deeper, then bias would also decrease.
Okay, sir. Okay, thank you.
Sir, in this class, could you please explain reduced error pruning with an example? Like, just take a set of numbers and each step, what happens in the reduced error pruning?
I don't have any specific example for that, but overall in reduced error pruning, what happens is that you are trying to reduce the size of the decision tree. So you want to remove some part of the tree, that is some sub tree you don't require. So basically for every node, if you delete the subtree rooted at that node, whether your the accuracy is decreasing sufficiently or not. If it decreases significantly, then you won't prune at that node. But if it is decreasing by a very small threshold, very small amount, you would have a threshold for that. That if decrease, let's say only 0.01%, then you might remove that decision tree completely. So that is what reduced error decision tree is. That you don't want to reduce the accuracy significantly, but still you will try to reduce the size of the decision tree. So is there any question regarding this in the assignment?
Yes, there is.
Yeah, but I don't have any specific example for that. So overall the idea is to decrease the size of the decision tree, basically the depth of the decision tree, so that at every node we try to remove the subtree rooted at that node if the accuracy does not decrease significantly. So this is the overall idea of that. You can rewatch the video lectures on that part, so it will be much more clearer. Question 4.
Lack of smoothness of a particular surface. It is a characteristic of decision tree.
That question is there in the assignment. I think I cannot answer that question right now. If you start asking questions from the assignment, that will be difficult for me. I cannot answer questions from the assignment before the deadline is over.
The answer to this question A.
Okay, so this question, fourth question is, when building models with using decision trees, we essentially split the entire input space using axis parallel hyperrectangles, polynomial curves of order greater than 2, polynomial curves of the same order as the length of the decision tree, and none of the above. Okay, all the answers in the chat are option A, which is axis parallel hyperrectangles. So this is actually correct. So in decision tree, the overall space is divided into blocks of hyperrectangles. I mean rectangles in case of 2D. If it the number of dimensions is more than 2, it becomes hyperrectangles, which would also be axis parallel. So option A is the correct answer here. In building a decision tree model, to control the size of a decision tree, we need to control the number of regions. One approach to do this would be to split the tree nodes only if the resultant decrease in the sum of error exceeds some threshold. For the described method, which of the following are true? First option is it would in general help restrict the size of the trees. Option B is it has the potential to affect the performance of the resultant regression or classification model. And option C is it is computationally infeasible.
Sir, in fourth question, can you please show that what exactly is the option A, axis parallel? What is axis parallel hyperrectangles? I
In case
understood the
of
formula.
if this is the 2D space, feature space. So first, this is first feature, this is second feature. So we in decision tree, the space is divided as these rectangles like this, because in the decision tree, let's say you pick axis node one, feature 1, then if the feature 1 is greater than, let's say 40, you go to this node. If it is less than equal to 40, you go to this node. So that means at x1 equals 40, you are drawing this straight line, and this region goes to the left subtree and this region goes to the right subtree. So this way you are creating blocks of rectangles, and each region would represent the one leaf at the end of the decision tree. So that's this is in 2D, and if we have more than 2 dimensions in the feature space, it would become hyper rectangles, because it divides the, and these lines are axis parallel, obviously, because this, if in this example x1 equals 40 is the straight line, that would certainly be parallel to the y axis, this straight line. So
Okay, okay.
yeah.
Thank you, sir.
Question 5. Yeah, I have already explained this question. So Raja Rao is saying option B. Deepak Srivastav says option A and B. So correct answers are option A and B. So overall this approach would restrict the size of the tree, so it would help in reducing the size of the decision tree. But it can potentially affect the performance of the model, because sometimes it might happen that you prune a part of the tree or the subtree, but if you had that subtree, the performance would have been better, accuracy would have been better. So the more deeper the tree is, the error would be lower and performance would be better. But in order to restrict the size of the tree, we are taking this approach. So that's why option A and B are the two correct answers here. Question 6. Consider a dataset with only one categorical attribute. Suppose there are q unordered values in this attribute. How many possible combinations are required to find the best split point for building the decision tree classifier? So only one attribute is there, that attribute is categorical in nature, and there are q unordered values, unique values you can find in that attribute. So how many possible combinations you need to investigate to find out the best split point for that attribute? Ritika Kesri, Deepak Srivastav, Indu Rajarao, Shikhar Tripathi are saying option D, which is 2 to the power q minus 1 minus 1. So the correct answer is option D. So in this question, basically q values are there, q unordered values are there. You have to split these values into two sets. So if the values are a2, a3 to aq, so this is the set we have, and we have to split this single set into two sets. So this can be done using permutations and combinations. So this can be NC0, NC1 up to NCQ. We can use this combination value. So NC0 is picking none for the first set, and NC1 is number of ways to pick only one, and then NC2 is not number of ways to pick two objects from this set, and up to NCQ. But this NC0 and NCQ we have to remove, because if in case of NC0 and NCQ, one set becomes completely empty and all the elements will remain in the other set. So this total value, this sum of these combinations would be 2 to the power q. This comes from binomial theorem. And if we remove this NC0 and NC1, this becomes 2 to the power q minus 2. And then you have to check that NC1 is same as NCn minus 1. Similarly, NC2 is same as NCn minus 2. So we need only one half of these additions. So we need NC1 plus NC2 to NCq by 2. So we have to divide this thing by 2. 2 to the power q minus 2 divided by 2, which is 2 to the power q minus 1 minus 1. So this is how we can calculate this number. Is it understandable?
Okay, sir.
Okay. Question 7. Decision trees can be used for the problems where attributes are categorical, attributes are numeric valued, attributes are discrete valued in all the above cases.
All the above.
Okay. Ritika Kesri is saying D, Archa is saying D, Vinod Govindan is saying D, Vijay Satish is saying D, Deepak Srivastav says D, Rajarao says D. Yeah, so all the answers in the chat are option D. And so the correct answer is option D, that in all the above cases. So in categorical, certainly we can do using decision trees. It is made for categorical values, obviously, and if the attributes are numeric valued, then we can discretize those numeric values into a finite number of bins, and then we can treat those individual bins as individual categories, and then again we can apply decision tree algorithm. And if the attributes are discrete values, it becomes same as categorical values. So even in that case we can apply decision trees. In a binary classification problem, out of 30 data points, 12 belong to class 1, 18 belong to class 2. What is the entropy of the dataset? Ritika is saying A, VG Satish is saying A, Rajarao is saying A. To find out the entropy of this dataset, you have to find out probability of each of these classes. So probability of the first class P1 is 12 divided by 30. Similarly, probability of P2 will be 18 by 30. So you have to use these two probability values to compute the entropy. The formula of entropy is minus of P1 log P1 plus P2 log P2, and these logs are base 2 logarithms. So this is the overall formula. So here you have to plug in these two values of P1 and P2, and if you plug in these values, you will get 0.97. Consider the following dataset. So this is a dataset consisting of 4 input features, and this malignant is the target variable. So you have to find out the initial entropy of malignant. For this target variable malignant, you have to find out the entropy. Fiji Satish is option B. Deepak Srivastava is also saying option B, which is 0.9798. Okay. Anyone else? Ritika Kesri is saying option B. Raja Rao is saying option B. So to find out the entropy of a target variable, you just have to find out how many elements are there for the class 0 and how many elements are there for class 1. So 1 2 3 4 5 6 7, so 7 elements are there for class 0, and 1 2 3 4 5 elements are there for class 1. So you just have to compute the fraction of elements in class 0 and class 1. So these are 7 by 12 and 5 by 12, and then you have to use the formula for entropy, which is minus 5 by 12 log 5 by 12 plus 7 by 12 log 7 by 12 with base 2. So this will give you the entropy, which is option B, 0.9798. Now question 10, again on the same dataset. What is the information gain for the feature vaccination? So vaccination is this feature. You have to find out the information gain for this feature. So for that you have to find out the total entropy of the dataset, which we have already computed in the last question, and then you have to subtract that total entropy by the weighted entropy of all the splits according to vaccination. Avrijit Shah says same problem is already solved in previous session. Oh, okay. 0.4763. Okay. Yeah, it might happen. Some questions might be similar in different live sessions. Shiva Chaudhary, you have raised your hand. Do you want to say something? Ajay Chauhan says option A. Okay, so for this question, as I already discussed, that first you have to compute the total entropy of the target variable, which is malignant in this case, and which we have computed in the last question. So the total probability needs to be calculated, which was this 0.9798, and then you have to compute for this vaccination there are two unique values, 1 and 0. So if in the left subtree, if the value of the vaccination is 1, we go to the left subtree, and how many the class 0, class 1 we are getting, that we have to calculate from here, that we have to count basically. So for these are the vaccination equals to 1 data points. So out of these data points, so all the elements in the left subtree are class zeros, which are 1 2 3 4 5. So 5 class 0 elements are there, and no class 1 elements are there. And in similarly in the right subtree, when vaccination value is 1, so these are the elements. And out of them, this is 0, this one is 0, so this one is 0 and this one is 0. So 2 class 0 and 1 2 3 4 5 class 1 data points are there. And how many elements are going to this left subtree and how many elements are going to the right subtree, that you also have to calculate. So there are 1 2 3 4 5. So the left, in the left subtree we have 5, and in right subtree we have 7. So this is 5 by 12, this is 7 by 12. So the total entropy minus, you have to compute this 5 by 12 into entropy of the left subtree plus 7 by 12 into entropy of the right subtree. Yeah, so this is the information gain. This is the information gain that you have to calculate. This E left and E right, they are the entropy values for left subtree and right subtree, which can be computed using these quantities: 5 of class 0, 2 of class 0 and 5 of class 1. So using these informations, you can compute this E left and E right, which are the entropy values for left subtree and right subtree respectively. And using this formula you can compute this information gain for vaccination, and which is option A, 0.4763. So this is also written here. This is the total entropy, 5 by 12 and 7 by 12. These are the fraction of elements going to the left subtree and right subtree, and this is the entropy of the left subtree, this is the entropy of the right subtree.
Sir, in this data set, which one will be the root of the decision tree?
The information gain we only computed for vaccination. Then we have to compute for the other variables also: age, tumor size, tumor site. So for all these 4 input features you have to compute this information gain, and you have to pick the attribute with the highest information gain out of these 4. So similarly you have to find out information gain for all these 4 features.
That means highest IG value, whichever attribute gives, that will be our.
Yeah, that will be our root. Yeah.
Okay, thank you.
Okay, so these were the practice problems that I wanted to discuss in this live session. And now if you have any other questions, you can ask me.
Good evening, sir.
Yes.
Sir, I'm Shruti from Mysore.
Yes.
Last week I asked about the links, so I'm not getting in the portal.
Yeah, so
Yes,
there is
I
a
got it.
yeah.
I got it. It's open,
Hmm.
but it is showing the YouTube links, not what you're explaining each class. There's problems what you're discussing, so it is not that link. The topic explained link is available in this Excel sheet.
Those were the live sessions recordings, right? uh, yeah, for me you will
Yes.
find the live session links for the TA name Ayon Maiti, and you will get all the recorded video YouTube links for from my YouTube channel you will get.
Sorry, sir.
So the YouTube recording links are already there in the Excel sheet, right? What else do you
Yes,
want?
it is there, but I want the problems what you're discussing in this class. I want the problems of
Yes,
that
those,
information.
yeah, there is another link for the presentations, I think.
There is only presentation folder link is there
Yeah,
here.
in the presentation folder you will get all the presentations.
Means this videos it is available in that folder.
Yeah, for week 6 it is not yet available. After this session is over, then I will upload. Up to week 5 you will get all the presentation PDFs in that folder called the presentation folder is there. Yeah.
Okay, sir. I'll check it, sir. Thank you, sir.
Okay.
Sir, what kind of a split will be chosen oftenly?
What kind of split?
Will be chosen oftenly? Training and testing split 50-50 or 80? What is the
No,
proportion?
not 50-50. Most of the data set should be in the training part. Otherwise, the model will not be trained well. So, like 80-20 or 70-30 sometimes. It depends on your task, how many data points you need for training. But you generally need more data for training and lesser data for testing, obviously.
Okay.
Sir,
Yes,
this is Ajay Chauhan.
yes.
So kindly, can you discuss about how we calculate the error at particular node during reduce error pruning?
Yeah, so in basically in reduced error pruning, you have to decide whether you want to prune that node or not. Pruning that node means you delete everything that is below that node in that subtree, rooted at that node. So if you remove everything in that node, what is the total accuracy of your model? So the decision tree would become shorter if you remove that node, everything under that node basically. So
Accuracy means about the
yeah, in case of for
what
classifications it would be accuracy for whatever metric you would use. For classification you might use accuracy, for regression task you might use a different metric. So basically whatever is your error measure, you will compute that with pruning and without pruning. If it does not decrease significantly, then you can prune it. Otherwise, if it is the performance is decreasing significantly after pruning, then you should not prune it. So this is how you compute it. And you compute for after pruning, you compute for all the test points and then see what is the error, and without pruning what is the error. Based on that you have to make the judgment. There should be a threshold that if this much is the difference between the error measures, then I should prune, otherwise I don't.
Okay. Sir, if complete tree is not given,
Yes.
if complete tree is not given,
Hmm.
some feature values given are at the particular node.
Uh,
Feature values are given at a node. And the
first first you have to build the decision tree, and then you have to decide whether you want to prune at some part or not, at some node or not. You have to first build the whole decision tree based on the dataset.
Okay. Thank you.
Sir, can you explain greedy approach in decision tree?
Yeah, there is the one question in the assignment. the greedy approach, yeah, if I tell you how to do that, then the assignment would become meaningless. But if you have any doubt regarding that question, you can post in the discussion forum. If you don't understand some part of the question, then you should post in the discussion forum, and the regular TAs who have said the question, they would be able to answer your question properly.
Sir, can you explain the sixth question of last assignment, assignment number 5?
What was that question? Question 5. Are you asking about question 5 of week 5, or which question?
Question 6.
Question 6, I think, is the explanation is also given in the solution PDF, that this fx parameterized by p, which is 1 minus p to the power x minus 1 into p. So this is the likelihood for every data point, and you have been given several samples. So this 4, 5, 6, 5, 4, 3, these are the different samples that you have been given. So you have to multiply these probability, these likelihood values for each of these samples. For x equals 4, you put this value of 4 into x, then then x equals 5, x equals 6, x equals 5, x equals 4, x equals 6. These are the different x values. You put those values in the likelihood function, which is given here, and you multiply this whole thing, and then you can take the log likelihood, so that the overall expression becomes simpler, and then you have to take the derivative of that thing with respect to p in order to find out the value of p, and then you will be able to find out the maximum likelihood estimation of p. It is something given in the solution set also. And once you find out this value of p, now probability of x greater than equals p, you have to find out, which is a cumulative probability distribution. So basically sum over this f x equals 5 plus f x equals 6 up to infinity, and it is a converging sequence, so you will get a converging value for that.
Sir, I wanted to ask that in the assignment, if for any of the question, if if we mark the options, say for example, we mark two options, but like when we get the answer, the correct answer is three options. So why when we get the solution, we for that question we get for that question we get completely 0 point. Why not at least 1 point, or or a fraction of some point is there for that question? Why we get completely 0?
Yeah, I don't know how many marks are given for that, but if you mark all 4 options, then you will get all you are certain to get full marks for that, but that's not how it should happen. Then everyone would mark all the 4 options, then you will get 100% marks for that question, but it shouldn't happen that way. So you have to choose only among the correct answers. If you choose 1 out of the 2 correct answers, you will get, I think, 50%. If you choose 2 out of 2 correct answers, you will get full marks for that question. But if you choose 3 out of 2 questions, then that means you are wrong in that question. You have chosen an option which is not correct. So in that case, you have to be given 0, I think, Otherwise you would be given 100% because you have chosen 2 correct answers but 1 wrong answer also. But in that case, if someone chooses all 4 options, he will get correct answer in all the questions in that case. Okay, if there are no other questions, we can end this live session here. Thank you everyone for joining.
Thank you, sir.